Hello and welcome to our new unit on angles and triangles. Um, it sounds like we're doing right triangle trigonometry again, like in geometry, but this is slightly different. So go ahead, if you want to go ahead and get this down, go for it. Pause the video if you need it. So I'm going to jump right to the actual page where we're going to start our notes. And we're going to talk about radians, degrees, and coterminal angles. So first things first, what is a radian? A radian is pretty much if you were to take the radius of any circle and you were to, let's say, pretend, let's actually draw one out. If we were to take, for instance, call this circle C. If I were to take this radius, I'm actually going to highlight this. I'm going to actually color it green. Okay. If I were to take this length like a string and I were to kind of see how many of these strings I could wrap around the circle, I would actually get about, let's say, one right here, 2, 3, 4, 5, 6, and then a little bit of change. So this radius would travel around 6 times. So this is 1 radii, 2, the 3rd, the 4th, 5th, and the 6th. And this 6th one would be approximately, so we start at 0 radii, and then we end at 6.28 radii. Now this is a very peculiar number because this actually sounds familiar. This 6.28 radii is actually half of pi, or double of pi, 3.14. So a radian in reality is how many times it will wrap around the circle. We know it will wrap around 6.28 times. Depending on your circle, it changes in terms of how long that is. But that's what it is. It is the length of the radius for a unit circle and wrapped around the outside of the circumference of the circle. So if we want a formal definition of it, let's give one. It is the length, the length of a radius of the unit circle. We don't need that anymore. The unit circle wrapped around, or wrapped along, I should say, the circumference and every radii. So it's the length of the radius of the length of the radius of the unit circle wrapped along the circumference. So depending on how far you go, depends on how many radii you have. So we have 1 radii goes about here, 2 would wrap around, and so on and so forth. So one thing to note is that it creates an angle. I probably should note that. The length of a radius of the unit circle wrapped along the circumference and forms an angle. So this is, if I were, for instance, draw in, let's actually use a solid color. Let's draw on something right at 1, okay? We start at 0 degrees, or 0 pi, and we create theta. The angle is created from our positive x-axis. And if you're wondering, if I were to wrap 1 radii around, starting at 0 pi, it would create, so this would be 1 radian, or 1 rad. Sometimes we call it rad, sometimes we call it radian. I'm going to call it radian. It's approximately 57.1 degrees. Okay? So, and then the full circle obviously is 360 degrees, which leads us to our next piece of information. So we should know that a circle is equal to 360 degrees, which is equal to 2 pi. Okay? Now, we could also write this as a ratio, as a fraction specifically. We could say 360 degrees, wow, that looks terrible, 360 degrees over 2 pi, which can actually be simplified because both of these are even numbers. So we could actually say 360 degrees can be divided by 2, so 180 degrees is equal to 1 pi. We could also flip this fraction around. So every 180 degrees is 1 pi. And then I'm going to put an or. We could flip the ratio. It's like saying every cookie recipe, for every cup of butter, it's 2 cups of chocolate chips, or 2 cups of chocolate chips per 1 cup of butter. Same thing. So you could say or pi over 180 degrees. Doesn't quite matter which one you do, but this is the ratio we need. Okay, one or the other. And depending on what you're converting to, dictates what you should actually use. So definitely have this starred or boxed somewhere. This is the conversion. Okay? This is your conversion. And then if you want to put a star next to that, go for it. So we need to convert degrees to radians and radians to degrees. So let's do that. Let's try a couple practice problems. So convert, let's start off, let's do radians to degrees. All right, starting off with something simple. Let's do 30 degrees, okay? So if we have, or not 30 degrees, let's go pi over 6. So pi over 6. Pi over 6 is the same thing as saying 1 over 6 pi, okay? And what we need to do is we need to convert it to degrees. So we are going to convert using this first ratio here, okay? Because the degrees is in the top, that's what we are converting to. We're going to take that and we're going to multiply by 180 degrees over pi, okay? And then if you notice, depending on which one you use, it doesn't quite matter. I actually prefer this first one. It's actually easier to work with. Either way you do it, pi's will cancel out. And then we get 1 times 180, 180, divided by 6, which is 30. And since this is in degrees, 30 is in degrees. And hopefully this makes sense, because when we started talking about the unit circle, that's how we actually got to those t values. 30 degrees was our reference angle. We built out the unit circle using all of these values. We actually used 360 over 2 pi instead of 180 over pi. And this is pretty much the same thing. This is the same lesson, except we're actually using radians now. Okay, so let's check out another one. So this is our first example. I probably should have put this A here. Let's try another one, B. Let's do pi over 4. Pi over 4, converting to degrees, that means we need to multiply by 180 degrees over pi, and in this case, pi's cancel out, which it should. And then unless you're working with some weird version of pi, never mind. 1 over 1 cancels those out. 180 divided by 4, it's equal to 45. 45 degrees is our angle. Okay? Let's try another one. Let's do 90. Well, or let's do actually something else. Let's do something in a different quadrant. Let's try 5 pi over 6. Multiply this by 180 degrees over pi. Pi's cancel out. And then we could actually start simplifying other places. 18 and 6. 6 goes into 18.3, so this is 30 degrees now, if you want to bring the 0 up. 6 becomes 1. 5 times 30 is 150. And that should also make sense because 6 pi is over here. It is a pi away, or a pi over 6 away, which we know is 30 degrees away. Okay? So that's pretty much what we do. We could always do more examples. For instance, what if we did 7 pi over 3? Well, 7 pi over 3 is actually bigger than 2 pi. And that's okay, because we know that even though we have a rotation that's over 2 pi, that just means it's going to land in quadrant 1 or quadrant 2. It's just going to repeat a lot of these patterns, but the degrees is slightly different. Where it lands is going to be this. It's going to be a repeat of quadrant 1, 2, 3, or 4, or one of the axes. But the degrees actually goes on forever, right? There's technically an infinite amount of degrees that we could work with. So we need to convert this appropriately. We're still going to be using times 180 degrees over pi. Pi's cancel out. Let's do that in red. And then we end up with, well, 3 goes into 18 6 times. So this becomes a 60. This becomes a 1. 7 times 60 is 4. So, well, 7 times 6 is 42. Add 0. 420 degrees over 1, or just 420. Okay? And you could repeat this process over and over. All this means is, hey, we had more than one full rotation. So that means we're going to have more than one full rotation in degrees as well. So let's try some converting the other way. Convert degrees to radians. Okay? If you note, this is always measured in terms of pi, just like our t values were, which is, they're essentially the same thing. There's a subtle difference between them, and it involves in terms of rotation versus length. A radian is actually an actual length, and that's why I should maybe underline that. This is the difference between t values and radians. Lengths cannot be, they're always positive. But convert degrees to radians. So let's start off with a value we haven't done yet. We see a 30, we saw 45. Let's try 60. Start off with A again. 60 degrees. And this time we're going to use this version of it because we're going to convert to radians or to a version of pi. So 60 degrees times pi over 180. If you want to put a 1 over this, you can. Notice that this is in degrees, so degrees will actually cancel out, which is an important feature because these didn't have degrees before. The degrees is what carries over. Now that we have degrees that actually cancel out, the units are canceling out appropriately. 60 and 80, 180 I should say. 60 goes into 180 3 times. 60 goes into 61 time, and we're now left with 1 pi, or just pi, over 3, which is in quadrant 1. Okay, try another one. B. Let's convert 120 degrees. So 2 different quadrant. 120 degrees over 1. Multiply that by pi over 180. 180 degrees. Degrees will cancel out. If you want to cancel out the zeros, you can. 12 goes into 18, or 6 goes in both 12 and 18. Goes into it twice for 12, 3 times for 18, so 2 pi over 3. radians. And I probably should put that here. Okay. B. C is done. Or not, B is done. C, I should say. Let us do something bigger than a full circle. 750 degrees. So same idea. Multiply by pi over 180 degrees. Degrees will cancel out. Zeros will cancel out. And then 75 and 18, they do have there's a factor that goes into both of them. It is for sure 3 at the very least. So let's see. 75 divided by 3 is 25. 18 divided by 3 is 6. Nothing else goes into 25 or 6, so we're in the right track. 25 times pi is 25 pi. 6, there's nothing else in the denominator, so it's just 6 radians. Okay? All right. The other thing we need to talk about is coterminal angles. So coterminal angles. Okay, so we've talked about t values that land in the same position. Okay, what this means is if we have, well, let's actually draw this out first. First, let's actually draw out an XY plane. Right. And if we, for instance, consider red, let's go blue. Okay. This is our initial side. We call this our initial side. Because this is where we start degrees, initial side. And if we have an angle that we start building around, we have what we call a terminal side. And maybe I should do that in red, just so there you go. Just because red means stop. Now, we call this particular angle here an angle. Okay, so this is a positive rotation. However, a coterminal angle means an angle that it lands in the exact same position as another angle. So if I took for instance, the negative rotation around, okay, and I call this angle alpha, then alpha and theta in this particular instance are both coterminal angles because they are landing in the same position. If I said, for instance, well, if theta was equal to 30 degrees, actually it doesn't look like 30, it looks like 45 degrees. And then since alpha is a negative rotation, we could say this is negative 315 degrees. These are coterminals, okay? So coterminal angles are angles that land in the same position. Much like t values, like for instance 0 pi and 2 pi, they're landing in the same position, or negative pi over 2 and 3 pi over 2. Okay, so In other words, they land in the same position, or they have the same terminal side. Terminal side. Okay, either way you want to think about it, it's the same idea, same thing. They are literally landing in the same position. So we could actually do this using positive and negative rotations. If I ask, for instance, to give, we'll graph the angle. Let's do this first. Graph the angle. Then find one positive and negative coterminal angle. Okay, so these are directions. So first one, if I said, for instance, 30 degrees. Okay, so let's draw that out first, really quickly. We know where 30 degrees lands. It is right about here. Okay, so that's your 30-degree angle. Now let's find another angle that is coterminal with it. So this is our terminal side. We need something else that is in that lands there. So what I'm going to do is I'm going to actually, let's start with the negative. I'm going to rotate around. Ooh, that's not right. Starting with the positive x-axis. That's always our initial side. We're going to rotate what looks to be about negative 330 degrees. Okay, and this is actually 100% correct, because these two should actually add up to 360 degrees if you take the absolute value of this negative 330. So that works out. But we also need a positive version of this. So what we actually need to do is we need to go beyond 330. We actually need to go beyond a full circle. So what I personally would recommend is going a full circle and then some around. And we know what a full circle is. A full circle is 360, but then we just add on the extra 30 degrees. So in this particular case, we could say another angle, let's call this alpha again, is equal to 390 degrees. In other words, I'm just going to take whatever angle this is, I'm going to add 360 to it, and that will be a coterminal angle. And technically, you could do that with this one with another negative 360 degrees. Another way to think about this is, what is negative 360 degrees, which is a full circle, plus the 30 degrees you have. Okay, so it's a different way to think about it. Either one works. They are both valid ways to do these problems. Let's try another one. Let's do, for instance, 7 pi over 6. Well, in this particular case, we don't know what the angle is yet, but we can solve for it. So in order to solve for this into degrees, we need to do our conversion. 180 over pi. Pi's cancel out. This is degrees, so that it should end up in degrees. 180 simplifies with the 6. 6 goes in 180 30 times. 7 times 30. 210. So this is our angle. Okay, that's our reference angle. No, that's just our angle, sorry, not a reference angle. So let's draw this out. Okay, 210 degrees, it's more than 180. We know 180 is right about here on the negative x-axis, so we have to go a little bit further than that, and there is our terminal side. Okay, so that means that's our 100, this is our 210. So if we needed a negative angle, a negative theta, well, like I said, I could do the negative 360 plus 210, and that is a negative 150. In other words, And let's do this in, let's change the original to black. Okay. Now this angle that we're solving for, this is going to be our theta. Theta is negative 150 degrees, which does make sense because it is a little less than a negative 180. If I put a negative here. Okay. And then let's do a positive angle, or yep, a positive angle. So that means we need to rotate more than that 210. And then in this case, it's going to be 360 plus that 210, which is 470 degrees. Okay. All right. Technically, you could also do this in terms of radians. So if I did this problem, I'm going to do this an alternate way. In radians. Okay, so let's draw our circle again. All right, and we do know that our circle, or sorry, our angle turned out to be 7 pi over 6. Okay, now an angle that would be, or coterminal, would be this, would be wrapping around. Okay, and in this particular case, we could also say that if we do a full circle, so that if we call this theta again, we know a full circle, and we would normally do a full circle, or in this case, a negative full circle. So that's negative 2 pi plus the 7 pi over 6. We could do some math here. Or if you just know your negative rotation, this will end up being negative 5 pi over 6. Okay? So this is a rotation, so this is slightly different. If we do an alpha version of this, we need to go at least a full circle around. And we end up getting what would be 2 pi plus 7 pi over 6. Okay, we could convert this. 2 pi and then 6, we need a denominator of 6. So it would be 12 pi over 6 plus 7 pi over 6, which is 19 pi over 6. So this would be the positive version of this. Okay? Okay. So essentially that's all this really is. It is converting to degrees and radians as needed, and then working with coterminal angles, which have both positive and negative rotations. Your homework is pretty much based off of this, and this is just the foundation for building around, building towards reference angles. You'll see what I mean in the next lesson. But for now, this is just a new way to kind of be looking at the unit circle in terms of, hey, now we actually have angles to use. If you do have any questions, please let me know, and I will see you in the next one. Bye.